Looks like it's running. Looks like it's running. Okay, let's get started. Yeah, perfect. Yes, so yeah, we are back again with our lead code array. Okay, so yeah, day 5 array. Uh, any I will be selecting easy questions, tags, array. Check it. Okay, so pick one. Uh, Pick a random one. Let's get started. Let's go. Come on, man. Java number of students doing homework at a given time. Okay, done. Next question. Nice. Let's see. Given two integers array start time and end time and a given integer query time. Start time, end time, query time. Okay. The ith student started doing their homework at start time I and finished it at end time I. Return the number of students doing their homework at the query time. More formally, return the number of students where query time lays in the interval of start time and end time, inclusive. Okay. Start time 1, 2, 3, 3 to 7. Its query time is 4. Query time lays in the interval 4. Okay. 1, 3. The first student started doing homework at time 1 and finished at time 3 and wasn't doing anything at time 4. The second student started doing homework at time 2 and finished it at time 2 and also didn't do anything at time 4. The third student started doing homework at time 3 and finished it at time 7 and was also doing homework at time 4. Okay, then when doing your homework at the query time, more formally return the number of students where query time lays. Oh, what the hell? Is that it? If 4 lies between 1 and 3, if 2 lies between 2 and 2, 7 lies between 3 and 4, only the time? Okay. Well, if I just need to like check if my query time is less than equal to, I will just be looping over these. If let's say I have a student I, let's say interval, time interval, let's say 1 and 3, start time and end time of I. If my start time, if my query time, let's say my query queue, we have a query time, right, should be less than equal to and greater than, should be greater than equal to and less than, should be greater than equal to start time, right, start time of I and my less than equal to query time of I. If it's this, if it's true, then not query end time, then like, yeah, then count plus plus, make count plus plus, else just continue. What, like end I equals to 0, I is less than start time dot length I plus plus, I will have int number of students. नाही मी नाही शकत, sorry. Number of students equals to actually 0. Right? My query time start start time dot length if my query time q my query is greater than equal to, let's say, start time, start time, yeah, and it should also be, and it should also be less than end time. My query time should also be less than equal to end time. And so a number of students plus and it is increasing. Otherwise, just continue. Start time of I, query time of I, not given. Time of I, number plus students number of students plus return number of students. So perfect. Yeah, it's O of n because I'm parsing the array, and time complexity and space complexity would be O of one constant, not using any data structure. Space O of n, time O of, no, space is of one, time is of n. Perfect. Plus well, can't use. Some constraints. If my start time dot length is 1, took that case, query time is equal to that. Start time of I is always less than end time of I. Okay, to summary. Obviously, it's 100% memory, should also be 100%. You can like memory instead of like. Okay, what's the use of this question? It's too easy to get it. Thinking that it could be a segment tree involved and then hit it and you keep it simple. Wow, like why is that even there? Be a solution plus glass. Oh shit! Did I stop the time? I don't know, but it's white. Uh, mm, 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 Problems. Yo. Easy tags array. Let's pick one. Okay, start the timer. You are given a zero text array nums and two integers key and k. Okay. You are given zero nums of distinct and all key distinct indices in an array. A key distinct index is an index nums for which there is a place on index k such that sorted in an increasing order. Okay. Let me just simulate it. 3 I is a 3. Okay. I will be passing. I feel like it's going to be a hash map type. Okay. Of I minus 3 should always be less than equal to k. Two integers. If I feel like it's going to be using two sum, I feel because it's contained I minus j is less than equal to k. I feel like that. Okay, let's move ahead. Solving 3. Key is 9 and key is broken. So 3 minus j should be always equal to k, right? And since it's not true, let's say my j is always greater than I, assuming initially, because yeah, perfect. So mod of j minus is always greater than k. So 3 minus j should always be less than equal to, let's say here in this case 1. So j should be always be greater than equal to, but it should also be less than something value. Yeah, but it also be less. It should also be less. Okay, so I should do 3. My key should be also be 9. Okay, let me just assume. Okay, key is 9 here and key is also 9 here. Okay, keys are 9. Numbers of equals to, so my j can, what can be my I values? Let's say 3, 0, 1, 2. Now it's 2. What can be my I values here? For index 2, what can be my I values? My mod of I minus j should always be less than equal to k or k 1. So my values can be 3. Right? My values can be 3. My values can be index 1. Right? In plus minus, doing my plus minus. Right? Now it's 0. So my answer should be 1 and 3 is 0, 1, 2. 2 is 2, always present 2. So 1, 2, 3. Then what's my index? 0, 1, 2, 3, 4, 5, 5. So I will have 5, 6, 4. So 4, 5, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. Perfect. So let me say first find key. Right? Let's say index of key. Let's say its index is, let's say I, which is equal to index. Okay. Key, let's say we call it key index. Key index. Okay. Now my initial value would be -1. My values would be key index -1, comma key index +1, comma key index. Yeah, these would be my values. Key index -1, key index plus, not -1, it's minus. It should be like less than minus, less than, till less than, right? It would be all values from all indices from key index minus k to key index plus k. So my values would be all values from indices would be answer indices, or let's say answer indices would always be greater than equal to key index minus k and less than equal to key index plus k, right? All values from key index minus k to index plus k. Now I need to put these values into an array, and that too in the sorting indices order, right? Now let's say my indices, I have indices values in the sense like 1, 2, 3, right? And here I have it's like 2, 3, 4, and 2, 3, 4. Now what I can do is like I can make use of an, let's say my answer array is a new array, okay? With the help of a pointer I am placing it. Now I do have values, so I will place 1, 2, and 3. Now it should be always be in the increasing order, right? So what I can do is like my next value should always be greater than the first, right? So I will check 1, 2, 2 is greater than, yes, 3, yes. Now I have here 2, 2 is less greater than 3, no, move ahead. 3 is greater than 3, no, move ahead. 4 is greater than, yes, place 4 here. Even if I have 3 values, say let's say 3, 4, and 5. 3 is greater than 4, no, 4 is greater than 4, no, 5 is greater than 5, just then I get 5. Those values must be increasing. So how my key index minus k2 plus k, right? So what I can do is first fill all the values. For that I can use a hash set. I can use a hash set, putting all values and then putting all the values to the from hash set to the answer array. But I feel like I need to dig this one out. 2, 3, 4, and 1, 2, 3, 1, like that. Let's say my answer indices are minus k2 plus k, right? So what if I put my answer indices into 1? So let's see answer indices. I will have with those values. I will be, let's say I have found key index. Now I'll be filling these values answer indices. So using a loop here, let's say key indices. Now then my answer of I should be equal to key index. Let's say I'm looping using my answer. It should be equal to answer index. Answer index. But my should be greater than its current value. So my answer index should be first greater than answer of I. Get it? Then only you can put an increase I. Then only you can put it into the answer of I. Next. Then can it contain negative values? No. Okay. Answer index would be if my answer index is like greater than answer of I, then add it. If then add, else continue. continue to move ahead. Put the next index, check the next index, and then add it to the answer of I would be like there, holding value. Perfect. I feel like this should be enough. So for I will be declaring an int I. That I let's see what should be declared. Let's say index is to 0. For int I equals to 0, I is less than equal to what's the nums dot line I plus plus. If my nums of I matches e, right, then for int k equals to 0, k is less than equal to what should be like k, not k should be, it should be my answer index. Let's say my answer indices, it's my answer index, right, it should be equal to index minus 1, it should be equal to key, here it is I, let's me here I, key index would be here I, and answer index would always be less than equal to I plus k, no, it should be I minus k, minus k, k I plus k, then I need to fill it into answer of index should, if let's checking first, if my answer of index is greater, is less than current value, nums of, no, if my answer is not answer of index, I'm putting answer of, I'm just putting it into indices, so yeah, current my answer of, let's say current is less than, if it is less than nums of I. How should I stop the stream? Hmm. How should I stop the stream? Hmm. Let's continue my lesson. Yeah. So let's just